Hi everyone, in this video we're going to start covering topic 2. We'll discuss naming chemicals and properties on the periodic table. So just a reminder that when you're watching these Edpuzzle videos to treat these like lectures and make sure that you take notes and write down any questions or things you don't understand and bring those to class so we can talk about them afterwards. So let's jump into it. So many of you may not know, but before the space race, there was actually a periodic table race. So around the mid-17th century, there was actually a big race to discover elements on the periodic table. A lot of these things weren't known. So there's actually a big timeline on Wikipedia if you want to see it, where you can see all of the different elements and the dates they were discovered and that sort of stuff. Many of the heavier elements on the periodic table, the ones like lower down, these are actually named after locations and things. Some of them have really weird names. So like polonium on the periodic table, fun fact, is named after Poland. This is one that Marie Curie discovered and she named it polonium. Americum is named after America. Berkelium is actually named after Berkeley University in California because it's a more recent element. I'm sure you can guess what Einsteinium is named for. Plutonium is named for Pluto, helium for the Greek god Helios. Germanium is actually named after the country of Germany. So there's a lot of people that will name elements to give credit to their discoveries when that happened. So in 1869, at the end of the 17th century, Dmitri Mendeleev here won the ultimate periodic table race. He actually was the one to assemble the entire periodic table, to take all of these elements that everyone had discovered and put them in some kind of fashion that makes sense and that arranges all of these things by physical and chemical properties. So let's take a look at where all these elements come from. This is their country of discovery. So you can see where all of the elements on the periodic table are actually discovered. We've got some in the UK, a decent amount in Sweden and in Germany, right? You'll notice most of the United States ones are down here at the bottom because they're more recent, because the United States wasn't actually around until until like later in the 17th century. So France, Russia, Austria, anyway. So you can see where all of these different elements are being discovered and actually named. So the periodic table was assembled by all of these smart people, and the reason it was assembled is so that everything in the periodic table has similar physical and chemical properties. Here's one of our element discoverers, Marie Curie, super famous. We'll talk about her whenever we get to nuclear chemistry. So physical properties are things like melting temperature, the temperature at which an element melts, how hard or dense something is, how tough it is, maybe the physical state it's in. Is it a solid, liquid, or a gas? Maybe how conductive it is, i.e. does it pass electricity through it or not? This is a chemical property. Some things are insulators and they don't pass electricity through them, and other ones are really, really good at passing electricity through them. So these are physical properties, properties that a substance exhibits. Now we have these chemical properties as well, things like explosivity, or reactivity, or the ability of an element to ionize, to turn into a cation or anion. And these are also grouped on the periodic table. And this is what we call chemical properties. It's something that is referring to a chemical reaction. Oh, also, I wanted to mention these periodic table videos. These are really cool. So if you want to see all these different properties of these chemicals on the periodic table, you can go to this website, and they actually have short little videos, like 5 minutes or less videos, that show all these different physical and chemical properties, interesting ones of the elements. We're going to talk about a couple of them today. So essentially, a physical property describes the physical characteristics of a substance. So things that you can observe, things like texture, hardness, luster, odor, how it smells, sounds, that sort of thing. Sometimes numerical descriptions, like how heavy is something, that's a physical property. Melting point, when does ice melt? It does at a specific temperature, and that's something we can consider a physical property. Same with boiling point. Water boils at a specific temperature, and that's a physical property. Chemical properties describe how the substance reacts with other substances. So that's a really good way to remember that. One thing that I like to think about at chemical property is like before and after something happens. If there's a new substance that's formed because of that property, then it's a chemical reaction. So if you start with iron and then you end up with iron oxide after a chemical reaction has taken place, that's a chemical property. So some examples of chemical properties that you might see a lot are flammability. If you light it on fire, you're going to end up with a different chemical than what you started with. If it's not flammable, flash point, also having to do with flammability. Rusting, that's what I was talking about earlier with the iron. Iron going to iron oxide. That's an entirely new chemical after that process takes place. So it can be considered a chemical reaction. Corrosivity of certain substances. And so you might hear that something is corrosive if it eats away at something. That's a chemical reaction. All right, so just to reiterate that point, characteristics, physical properties are characteristics that can be determined without changing the substance's chemical identity. So if you start with iron, you end up with iron, then it's a physical property. If you start with iron, you end up with iron oxide, chemical property. So let's look at physical changes. So a good example of this I like to use is water. This is the chemical structure of water. So water can be at different physical states of matter. So it can be a solid, a liquid, or a gas. So water undergoes physical changes. It can be frozen to become a solid. It can be melted to be a liquid. And it can be boiled to become a gas. But at the end of the day, you're going from H2O, solid, to H2O, liquid. There has not been a chemical change in the composition of this compound. It's still H2O. That hasn't changed. It's just in one form it's frozen and the other one it's not. So this is what we call a physical property, a state of matter. So this is your physical property. So going between these different states here is a physical change. It is not a chemical change. So this is a change that does not alter molecular composition. Same element or molecule or compound is present before and after a change occurs. Okay, so go ahead and take this quiz now and identify which of the following are chemical or physical properties. Remember that your answers may include more than one of these. So several might be chemical, several might be physical. Okay, so let's look at the answer here for this one. Chemical properties are going to be things that before and after there's a different substance. Physical properties, you start with one thing, you end with the same thing after the reaction happens. So flammability is a chemical. Boiling point, think about water. If you boil water, you aren't changing the substance. So this is a physical property. Mass of a substance, how heavy something is, that's also going to be a physical property because you aren't changing the identity of the substance when you measure this amount. Corrosivity, again, that ability of a chemical to eat away at certain things if left in contact with them for a while. That's going to be a chemical. It's a chemical reaction happening there. Conductivity, the ability of a substance to pass electrical current through it, also another physical property. So think about a computer chip. You start with a computer chip, you run electricity through it, afterwards you still have the same computer chip. The chemical composition of the elements inside of it have not changed, it's just had current passed through it. Let's look at changing states of matter. So these physical states that we talked about, solid, liquid, and gas, can go through changes. So we can go from one state to another state. We often do this by adding heat to the system or removing heat from the system. So you can think again of water. When you heat it up, it's going to go from the solid to the liquid to the gas. If you cool it down, it's going to go the other way, gas, liquid, solid. And so we have names for these different changes for going from one state to another state. So one of these is, so we've got freezing, melting, condensation, vaporization, sublimation, and deposition. All right. So do note that this heat here, this is energy. And something that's interesting here in these pictures, you'll notice this is a molecule. And you'll notice that the solid molecules are really close together. The liquid molecules are a little bit further apart, and the gas molecules are much further apart. And so by putting heat into the system, we're seeing these things pull apart. And we're going to discuss this more in another topic, but I do want you to observe that difference. Okay, so let's look at where all of these different processes are applied. So freezing is when we go from a liquid to a solid. Melting is the opposite. We go from solid to a liquid. So just like an ice cube melting. Condensation. This is what happens when you go from a gas, so like water vapor, into a liquid. So this gas to a liquid. I'm using water for all of these examples, but do know that most chemical substances can undergo any of these processes. Some of them don't undergo certain of the processes, but the majority of them do. Vaporization is the opposite of condensation. We're going from a liquid to a solid. So sometimes you might hear this called boiling, or even evaporation. They're all describing the same process of going from a liquid to a gas. And then these last two that you may not have heard of, sublimation and deposition. So sublimation is a property that not all chemicals exhibit. Same with deposition. This doesn't often happen for all of them. But it's when you go from a solid straight to a gas. There's no liquid. So this is when you go from solid straight to a gas. I'm going to show you an example of this. And then deposition is the opposite. We go straight from a gas to a solid. And very few elements naturally exhibit this. Oftentimes we have to manipulate a substance in order to get it to do this. Okay, and we already talked about that. That's in another topic. So we won't talk too much about that now. Okay. So those changes that I talked to you about, these are often related to our physical properties. So melting, like here, there's a certain temperature at which each substance melts, and we call this a melting point, which is a physical property. So these are all physical properties here. So I want you to know that these boiling point is related to the process of boiling or vaporizing. Vaporization point refers to vaporization. And condensation point refers to the process of condensing. So the temperature at which these happen is the point at which these happen. So temperature at which a substance undergoes this process is the that point. So temperature at which a substance melts, melting point. Temperature at which a substance boils, boiling point. So on and so forth. So you can do that with all of the different physical changes that we discussed. Okay, so I really want you to see what deposition and sublimation looks like because it's really, really cool. So let's take a detour and go to YouTube here real quick. Okay, so I've got my sound off here, but we're going to look at the sublimation and deposition of iodine. So iodine at room temperature is a solid. These actually look like tiny little blueberries. They are not blueberries. And so this person's going to take the iodine and they're going to heat it up. And you're going to see that it's going to go straight into a gas, this purple gas. It's a really, really pretty color. So there's no liquid in here. There's just solid beads at the bottom, and it turns straight into the gas. Now what they're going to do is they're going to condense it. So they have ice in the top flask that they put on top of the beaker, and so the gas is going to reach up and expand upwards, and it's going to condense around the cold flask. So they got heat on the bottom, cold on the top. And so I guess technically we can't call this condensing because this is sublimation. This is not condensation. And so if you look here, those are crystals. Those are solid crystals of the iodine reforming onto the cold surface via the gas. So that's the process of sublimation and deposition. Iodine is one of the natural elements that does this on its own without much manipulation. Okay, so go ahead and take a second and see if you can answer this quiz here. What you're going to want to do is you're going to want to label all of these arrows with the physical change that is appropriate to the arrows that are depicted. Okay, so what we're looking at here is we've got going from a solid to a liquid. So this is our melting. Liquid to gas is boiling or vaporization. A here, going down from our gas to our liquid, is condensation. Liquid to solid is freezing. And then going from a solid all the way to a gas, that's your sublimation. So that goes to E here, sorry. And then B over here, going from a gas straight to a solid, is deposition. It deposits onto the surface. Okay, so that's the answers to those quizzes.